All right, here's the syllogism we're going to work with. All bees are threatened. Nothing threatened is safe. Therefore, some bees are not safe. Now, what you're going to do is you're going to translate this into standard form, thinking very carefully about how you do that and making sure that your translation has all of the criteria for an argument for a syllogism to be considered a standard form categorical syllogism. And then you're going to translate this argument into symbolic form using letters to represent your terms. And then, the fun part, you're going to use that step-by-step process to create a Venn diagram that represents this categorical syllogism to determine whether it's valid or invalid. If you look at your resulting Venn diagram after you've marked the premise statements only and you do not see the conclusion, then you should be able to determine that this argument is invalid from the Boolean standpoint. It should not appear in your unconditionally valid forms inventory. If the argument is invalid from a Boolean standpoint, though, you should shift your perspective to the Aristotelian standpoint. And to do that with a Venn diagram, you're going to do this. You're going to look really carefully at those three circles that comprise your Venn diagram, and you're going to look to see if for any of the circles, all of the areas except one are shaded. So you look at those circles, and if any of them have just one area that is open for members of that category to be in, there's just one area that's unshaded, you're going to mark a circled X in that area. And then you're going to come back and you're going to look at your argument again, and you're going to see if now, after marking your circled X, the conclusion statement is reflected in that diagram. And if it is, that argument is conditionally valid from the Aristotelian standpoint, and you need to ask yourself, okay, is this argument about things that actually exist? And if it is, we've met the condition for validity. All right? So what I want you to do is I want you to pause your video, carefully work through this step by step. It's a really important opportunity for you to be doing this work and being able to get, kind of feedback on what you're doing before you try to tackle these things in your homework problems. So go ahead and pause your video, and when you're ready to check your work, restart it. All right. Fun stuff. Okay, here's how I translated this argument into standard form. All bees are threatened insects. No threatened insects are safe insects, therefore some bees are not safe insects. Next, we're going to move on to symbolically represent this argument, and we're going to do that by using B to represent bees, isn't that clever? T to represent threatened insects, S to represent safe insects, and now the argument becomes this. No T or S, all B or T, therefore some B are not S. Now, if you're looking at my argument and you're thinking like, wait a minute, dude, you got the premises in the wrong order. Remember, standard form requires that the predicate term of the conclusion, the major term, appear in the first premise. And in the original rendition of the argument, it was in the second premise. And the minor term, which is the subject of the conclusion, is supposed to appear in the second premise. But in the original rendition of the argument, the minor term was in the first premise. We've got to flip the order of those premises. Otherwise, we're not going to be able to determine the form of the argument correctly. And we might not then be able to evaluate or check our work with the Venn diagram by consulting our inventories for valid forms of argument. All right. So now what we're going to do is we're going to move on to mark our premise statements only. They're both universal, so it doesn't matter which one we mark first. I'll just start with no T or S. I want to eliminate the area of my Venn diagram where there's any overlap between the S and the T circle, or the T and the S circle. That's areas 3 and 4. So we turn out the lights there. There's nobody home. And I move on to my second premise, all B or T. I want to mark this B circle so that all of the B's that exist are up here in the T circle. So I'm going to have to shade in areas 5 and 6. And now I'm done. And I look at my Venn diagram and ask myself, do I see in this Venn diagram the conclusion statement, some B are not S? And the answer is no. If I did, there'd be an X right there. But there's not an X right there. So that tells me that this argument is invalid from the Boolean standpoint, and I can check my judgment. And just before I throw down with my answer that this is an invalid argument, I'm going to look at the form of this argument. It's an EAO in figure 1, consult my unconditionally valid inventory, and I don't see that mood listed under figure 1. So I can be really confident that this argument is invalid from the Boolean standpoint. But let's shift our perspective, and let's look really carefully at our T, B, and S circles and ask ourselves, is there any one of these circles where there's only one area remaining open for membership? I can see in my T circle that there could be T's in area 1, area 2, or both. I just don't know where they are. So that my question doesn't, the answer to the question for the T circle is no, this is not a circle that has only one area remaining open. But the B circle is, area 2 is the only area where any B's can be. So if they're all there, there's got to be at least one there. Same thing with area 7. It's the only area where any S's can be. So if they're all there, there's at least one there, and I get to mark my X with the circle around it. And actually, we only need to put an X in one of these areas, but we'll cover that in our next thought primer. But for now, we've marked this Venn diagram exactly as I instructed you to. We put a circled X in any area of our circles that has only one unshaded area remaining open, and now we do see our conclusion statement, some B are not S. That B would be right here. That B that's right here in area 2 is outside the S circle. It is not an S circle. And that tells us, I think this argument is conditionally valid from the Aristotelian standpoint. Let me check my inventory. Do I see EAO listed in the figure 1 column? And I do. That tells me that this argument is valid, conditionally valid from the Aristotelian standpoint. And remember, there's a condition that has to be met. And my inventory tells us what that condition is. The subject term of the conclusion, the minor term, has to refer to an actually existing thing. Do bees exist? Yes, bees are real. Birds aren't, but bees are. So that tells us this argument has met the condition for validity. We don't have to worry right now about whether or not S exists, and we're going to talk about that in the next thought primer. For now, when you're determining whether or not a given categorical syllogism is conditionally valid from the Aristotelian standpoint, or has met the condition for validity from the Aristotelian standpoint, use your inventory to determine what the critical term is, what the term is that has to refer to an existing thing. All right.